Let's have a look at this question. Question says, if two disks of moment of inertia I1 and I2 are rotating about collinear axis passing through their center of mass and perpendicular to their planes with angular speed omega1 and omega2 respectively in opposite direction, they are made to rotate together along the same axis, then the magnitude of new angular velocity of the system is. So what is happening? We earlier have the angular velocities as omega1 and omega2 in opposite direction, and finally we are bringing the two disks together. So this is our white disk and we place the yellow disk on top of this white disk. Now what will happen? Now as you can see, initial angular velocities were different. These two disks will rub on each other. Lot of friction force will be acting, lot of noise will be produced, lot of heat will be generated, and there will be huge loss in kinetic energy. And finally, these two disks will rotate with peace with common angular velocity, let's say omega. We have to find what is this common angular velocity omega. This is the question. Did you understand the question? Yes. Now, how are we supposed to solve this question? Well, I will suggest you can apply the conservation of angular momentum of this entire system about our axis of rotation. You will ask how? How do we apply conservation of angular momentum? Well, when there is no net external torque on a system, we can say the initial angular momentum of the system is equals to the final angular momentum of the system. This is law of conservation of angular momentum. Okay. But why is there no net external torque on this system? Friction force is acting, so there must be torque. Yes, friction force is acting, but if you consider some element, let's say there is an element on the yellow disk and there is an element just below the yellow disk which is on white disk. So let's consider these two elements. Now friction force on the element on yellow disk will, let's say, act in this direction. And the friction force on the element on the white disk will act in opposite direction. So if we consider the torque due to these two friction forces particularly, the torques will cancel out. And this will happen for all the other elements also. So if we look at the net entire system of these two disks, there is no net torque due to frictional forces. So we can conserve the angular momentum of the system about this axis of rotation, right? Now let's see the options. These are the four options and one of these will be right. So let's apply conservation of angular momentum. L initial is equals to L final. Now these are the vector quantities. So let's talk about a direction. I will consider the upward direction to be the direction of y-axis. Okay? Yes. Now let's look at omega1. Omega1 is, as you can see, is anti-clockwise in sense. So we can see that the direction of this angular velocity is upward, which is j cap. So we have angular momentum as I1 omega1 j cap. Yes? Okay. Now let's look at the initial angular momentum of the white disk. Now this omega2, as you can see, is in clockwise manner. The other one was anti-clockwise and this one is clockwise. Okay? Yes. Now, what about this omega2? What is the direction of omega2? You will say it is directly downward. Yes. So we have the initial angular momentum as I2 times omega2 and we have minus j cap. So let me put minus sign over here. Minus and I will say j cap. Now what about the final angular momentum? Final angular momentum of the system is equal to, finally they are both rotating with common angular velocity omega. So L final, I will say this is equal to I1 plus I2. This is the total moment of inertia of the two disks combined and they are rotating with same angular velocity, which is omega j cap. This is the final angular momentum. So let me just put down this angular momentum as I1 plus I2 and we have common angular velocity omega j cap. Nice. From this we get the value of omega and we will get the answer. So what is finally our omega? Omega comes out to be I1 omega 1 plus minus I2 omega 2 minus I2 omega 2 divided by I1 plus I2. This is the answer. Now let's see the options, and we can see that option B is the right answer for our question. Let's have a look at this question. A pulley is rotated about its axis by a force 20t minus 5t square. So this is the magnitude of our force, and our force is acting in perpendicular direction to the radius vector, right? Okay. Now the force is applied tangentially, and we have to find the angular impulse on the pulley in the initial 2 seconds. Given the radius of the pulley is 0.5 meter. So what do we have to find? We have to find the angular impulse. Oh, what is this angular impulse? Angular impulse is nothing but just change in angular momentum for a short duration. So angular impulse, I will denote it with a symbol J vector. If you like any other symbol, for example Z vector, you can pick your own symbol. So J vector is nothing but change in angular momentum, delta L vector. Okay. Now, how to find this delta L? What is this change in angular momentum? How do we find that? Well, can you see that the moment of inertia of this pulley is constant? Yes, moment of inertia is not changing, we can see that. Now, when the moment of inertia is not changing, we can say change in angular momentum is given by integration of torque dt. Yes. So this is the magnitude of change in angular momentum, which will give us magnitude of angular impulse. Okay. Now, let's put the value of torque and get the answer. But how to find this torque? What is this torque? Well, actually, torque is nothing but R vector cross F vector. Do you remember this formula? R vector cross F vector? Yes, we do. So this is nothing but RF sine of angle between them. What is the angle between R vector and F vector? As we can see, R and F are perpendicular to each other. Yes. So angle between them is 90. Yes. Now, sine of 90 will be 1. And now let's put the value of R. R was given in the question. R was 0.5. This was given in the question. Okay. And something about time was also given. Time was varying from t is equals to 0 to t is equals to 2 seconds. And in this 2 seconds, we have to find what is the angular impulse. Okay? Yes, we understand it. Now, we find the torque. Torque is nothing but half, which is R. R is half times F. F is 20t minus 5t square. This is our good torque. Okay. Now we have to perform some integration. So integration of torque dt. Yes, integration of torque dt. What are the limits of integration? If you can tell me the limits of integration, I would give you a chocolate. Oh, limits of integration. In our question, they said we have to find the angular impulse in 2 seconds. Yes. So limits are from 0 to 2. Haha. Now let me give you a chocolate. This is your 5-star. Enjoy and have fun. Let's put the limits and find out what is the integration. So we have half, and then we have this integration 20. Let me divide 20 by 2 straight on. So we will get 10, and then we have t square by 2. So we have 2 square divided by 2, and then we have about 5 by 2. Then we have t cube by 3. So we have 2 cube divided by 3. So 1 2 gets cancelled out, and 1 2 gets cancelled out, and now we are left with something like this. We are getting 20 minus 20 by 3. Yes, 20 minus 20 by 3. This means 40 by 3. Can you see that? Yes. So what is our impulse? Our impulse has the magnitude 40 by 3. Let me write it again. Impulse has the magnitude 40 by 3. I hope you can see that. Yes. Okay. So we finally got the answer. J is equals to 40 by 3. And we can go and mark option C as the right answer for our question. This question is based on angular impulse. Question says, a rod of mass 2 kg of length 1 meter is pivoted about its one end. That's so nice. So here we have a really heavy rod, 2 kg, and its length is 1 meter. And we pivot it about its end. Nice. Initially it is rotating about its axis in the horizontal plane with an angular velocity 2 radian per second. So this rod is rotating in the horizontal plane with 2 radian per second. Okay. Suddenly an impulse J vector is given to the rod, because of which its angular velocity becomes 10 radian per second. So final angular velocity is 10 radian per second. That's greater than 2 radian per second initial angular velocity. Okay. Find the magnitude of angular impulse J vector. So we have to tell what is the magnitude of angular impulse. This is our question. Okay. So how are we going to solve this question? Let's see the initial and final cases. This is the initial case. The angular speed was 2 radian per second. And the final case is the angular velocity is 10 radian per second. Okay. So we have these two cases. Now, what is the formula of angular impulse? What is the formula of angular impulse? Well, J vector is nothing but delta L vector. It is change in angular momentum in a really short duration. Okay. Now, how to find change in angular momentum? Well, so simple. It is nothing but L final vector minus L initial vector. Okay. So we are talking about some direction. So let me take the upward direction as positive. Okay. And the downward direction as negative. Nice. So final angular momentum. For our case, final angular momentum is moment of inertia of this rod about its axis, which is passing through its end, times omega final. And final angular velocity, as you can see, is plus 10. Omega final is 10. And we can see initial angular momentum. This is nothing but moment of inertia I times omega initial. Yes. So we get I times omega final minus omega initial. What is final angular velocity? It is 10. And what was initial omega? It was 2. So 10 minus 2. And what is this moment of inertia about this axis? Come on, you can tell me. What is the moment of inertia of this rod about an axis passing through its end, and the axis is perpendicular to rod? What is the moment of inertia? The moment of inertia is 1 by 3 ml square. 1 by 3 ml square. What was mass? Mass was given to be 2 kg. This was really heavy. And what was L? L was given to be 1 meter. Okay. So let's put the values. Mass is 2 kg. So we get 2 by 3. And L we put as 1 meter. So 1 square is 1. And 10 minus 2 is 8. So what are we getting? We are getting something as 16 by 3. Yes. This is the angular impulse. 16 by 3. And let's talk about the direction. The direction of this angular impulse is positive, plus 16 by 3. So angular impulse is in upward direction. Nice. Anyway, we have to find the magnitude. So magnitude will be 16 by 3. And we can mark option D as the right answer for our question. Let's have a look at this question on rolling motion. Question says, consider the general motion of a wheel of radius 2 meter, which can be viewed as the combination of pure translation with the velocity v and pure rotation about O with angular velocity of 5 radian per second. Which of the following is incorrect? Now what is happening? Wheel is going like this. It is under rolling motion. Rolling motion is the combination of translation and rotation motion. And we can see that here are some points A, B, C and D. And what are the options? These are the 4 options. We have to pick the incorrect option, not the correct one, the incorrect one. Okay. Now, all the option deals with the relative velocity. Velocity of A with respect to O, velocity of B with respect to O, velocity of C with respect to O, and velocity of D with respect to O. So we have to tell the relative velocity with respect to O. Now, if you can go and sit at point O, what can you imagine you will see? If you sit at point O, what will you see? Can you imagine that? Yes, we can. Actually, when we are sitting at O, when we are in the reference frame of the center of the wheel, then we will see only pure rotation of the wheel around us. Yes, this is what happens. See, you have seen the axle of a car. With the reference frame of that axle, in the reference frame of that axle, the wheel is under pure rotation. And if we stand on the ground, then we see that the axle is moving in the horizontal direction and the wheel is rotating about the axle. So we see the combination of translation and rotation motion. But if we see the situation in the reference frame of the axle only, then we will see only pure rotation motion, right? Okay. Now, in reference frame of O, we will see that A is going in the backward direction, D is going in the upward direction, C is going in the forward direction, and B is going in the downward direction. This is because in reference frame of O, the wheel is rotating with angular velocity omega. Only this much is the motion in reference frame of O. Is that clear? Yes, it is very, very clear. Now, let's try to find out the exact velocities. Let's see, the magnitude of velocities are omega times r, because the distances of all these points is r from the center. So the speeds are omega times r. Omega is 5, r is 2, 5 2s are 10. So omega times r is 10 everywhere. So the speeds are equal, but the velocities are different. The directions will be different. Yes? Okay. Now, let's take the horizontal axis as the x-axis and the vertical axis as the y-axis. We have the direction represented by the unit vectors I cap and j cap. Fine? Fine. Now, first of all, velocity of A with respect to O. What is this relative velocity? With respect to O, A is moving in the backward direction with 10 meter per second. So we have minus 10 I cap. Can you see that? Yes, we can. And in fact, option A is true. This option says velocity of A with respect to O is minus 10 I cap. So it is true. Okay. And let's see option B. Option B says velocity of B with respect to O is minus 10 j cap. So in which direction B is moving? B is moving in the downward direction. Yes. So what should be the direction? Direction should be represented by minus j cap. Exactly. So we have minus 10 j cap. This is the velocity of B with respect to O. So option B is also true. Option C says velocity of C with respect to O. Can you see the point C? Yes, we can see the point C. C is at the top. Now with respect to O, C is moving in the forward direction with 10 meter per second, right? Right. Now the relative velocity of C with respect to O is 10 I cap because it is moving in the forward direction. Okay? Yes. So option C is also true. And what is the velocity of D with respect to O? Velocity of D with respect to O. Point D is moving in the upward direction with respect to O, right? Right. Now, upward direction at the unit vector j cap. Okay? Okay. So, velocity of point D with respect to O, this must be 10 j cap. And option D says it is minus 10 j cap. No, 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 no. Option D is surely false because with respect to O, point D is not moving in the downward direction. It is moving in the upward direction. Okay, okay. So we got all these relative velocities and we can see option D is false. And we had to pick the incorrect one. So option D is the only option which is false. So we pick option D as the answer for our question. Let's have a look at this question on rolling motion. Question says, a ring of radius 2 meter performs combined translation and rotational motion on frictionless horizontal surface with an angular acceleration of 4 radian per second square and the acceleration of the center as 4 meter per second square as shown in the figure. See how the wheel is going. Shoo. The center of the wheel is under the acceleration of 4 meter per second square, and there is some angular acceleration of this wheel also about the center. Okay. Now we have to find the acceleration of point D. We have to take omega is equals to 0. So what is the total acceleration of point D? Total acceleration of point D. This is the question. Do we understand the question? Yes. These are the options. Now, as we can see, the total acceleration of point D has many components. Now let's talk about each component separately. Due to the translational motion of this wheel, the center of the wheel is actually under some acceleration in the horizontal direction. Due to this acceleration of the center of the wheel, point D will also have one part as this acceleration in the horizontal direction. Okay? Now let's talk about the rotational motion, because this wheel has many aspects, translation motion and rotation motion as well. So let's talk about the rotational motion now. Now rotational motion is about the center of the wheel. Okay. Now if we see that there is a tangential acceleration of this point. Why? Because the wheel is under an angular acceleration alpha about the center, right? And this tangential acceleration has the value r alpha. Oh, so this point is under tangential acceleration. Is that all? Is that all the acceleration point D has? No. Point D has omega square r. This is the centripetal acceleration also. Don't forget this. Omega square r is towards the center. In our question, they gave omega is equals to 0. So we can place this omega square r as 0. So the total acceleration of point D now will be ai cap, and we have r alpha j cap. As you can see, I have taken the horizontal direction as the x-axis, and we have taken y-axis in the vertical direction. Okay? Yes. Now, ai cap. What is a? A is nothing but 4. So 4i cap. What is alpha? Alpha is 4 and r is 2. So r alpha becomes 4 times 2. 4 times 2 is 8, and we have 8j cap. Hooray! So we finally got acceleration of this point D. Acceleration of point D is 4i cap plus 8j cap, and we can mark option B as the right answer for our question.